everybody. Today we're going to talk about how we actually carry out these repairs. How do we figure out how to fix these devices? And how our job is really complicated by the manufacturers not being willing to give us access to parts and information that we need to fix these things. So what I have in front of us today, this is a relatively new iPad Pro. This is the 10.5-inch iPad Pro. Now this device was a 1 year old in March. So it is just outside of its 1 year warranty. And the complaint is that it doesn't seem to turn on. And you can see as we look at this device, it has a fairly minor but not insignificant bend. There's a little bit of flexion, and that's pretty typical with the iPad Pros. They get the bendy flexion damage that's really common across all of these products. So how are we going to fix this? First, let's see what our options are. What if we just don't fix it? Let's see what would it take if we went to the manufacturers and investigate the manufacturer support for repair or replacement of this device. Okay, so let's head over to apple.com, and there's the Apple Give Back program. Let's see how much money we can get. Let's just trade it in. That'd be easy, and we'll get a new one. So let's see, where do we figure out how much do we get? Yes, select the device. This is a iPad. This is an Apple iPad Pro. And, all right, does your device turn on? No, it doesn't. Throw it away. Recycle my beep. All right, so they're not going to give me anything for this device. No, screw you, pal. All right, next, what about repair? So it's broken. Let's go over to support.apple.com and find out our repair options. How do I get my iPad fixed? Oh, looks like it got options. Store, mail in, how much does it cost? Okay, if your iPad is considered out of warranty and not covered when it's over 1 year old. This iPad is just over 1 year old. This is the 10.5-inch iPad Pro, and I can pay $450. This is my out of warranty swap option. So I can turn this one in with all of my data and pictures on it and turn it in, and I can get a refurbished one from the last guy. I pay $449 for the privilege of giving them back this iPad and leaving with a refurbished one. Well, screw that. I'm just gonna get a new one. How much does it cost if I want to get a new one? I click through here and I can get an 11-inch iPad Pro, assuming this is Wi-Fi, and the smallest storage available, 64 gig. $800. So I could throw this one away, replace it for a new one for $800. I'm gonna try to fix it. I don't want to just get a new one. I don't want to turn this one back into Apple and have them chop it up. I want to repair it because I don't like the idea that we're just digging up metals out of the earth to keep this constant farm of new iPads. Why are we doing that? I love this article. Read this. This is from Motherboard Vice and Jason Kohlberg's reporting, and he's now the editor over there, and they do a lot of really good work reporting on exactly what goes into an iPhone. This article has really stayed with me. This is where they went to Cerro Rico in Bolivia, and they actually went down in these mines, and it was terrifying. Kids as young as 6 years old are forced to go into these places to dig up the stuff out of the earth that makes a new iPad. And, you know, it's really not a good thing. I mean, it's really not. And especially this line that this mountain has been carved out so thoroughly that geologists say the whole thing might collapse, taking the city down with it. 15,000 miners, some of them kids as young as 6 years old, specifically kids. They send the kids into the deep, dark parts where the adults can't go, the most dangerous parts. And people die in there. it's not a good idea. Why are we doing that and taking this iPad, throwing it away? I'm not sure that as citizens of the world that we have the right to do that. I mean, we have the right to do that, but what you know, can you really look your great-great-great-grandchild in the eye and go, yeah, I just threw it away because, you know, I got it right. I can do what I want. Give me a new one. It's something to think about. So I think that the idea that we should have an option to repair, maybe it's not always feasible to repair, but the more options to repair things, the better. And I'm a huge fan of supporting access to parts and information, and that's what the right to repair is all about. So let me show you, what does repair look like right now in the absence of a lot of manufacturer support. They don't give us information. They don't give us fair access to quality parts. We have to go really hard back to the original sources to find parallel supply chains. We have to refurbish a lot. You know, these screens for these iPad Pros, we are getting by re-glassing the original LCDs when they crack, and we're doing that with partners here in the US. That's really difficult. I would really like the option to be able to just buy quality controlled original parts from the manufacturer, just like you can for your car or any other device that a long history of repair has been fixing for a long time. I don't think that we have, as stewards of the earth, I don't think that it's a good idea for us to live our lives without an option for feasible repair. Okay, so this is a test screen that's sitting on this iPad, so I can easily take it off. Taking it off the first time was a lot more difficult. All right, so the screen's up. Now I'm going to disconnect the screen with the best tool there is for the job, the human professional fingernail. You got to have those pro nails. Let's take a look at the board and see if we can see what's wrong just using the eyeball method. To the microscope. When you're working on iPad Pro, having the battery disconnected is really important. These are very finicky, and remember, just because you have the device turned off doesn't mean that there's no battery voltage. There absolutely is. The battery is still connected, so that battery voltage is pushing into and filling up all of the arteries of the main power and battery power rails in the device. So you have live voltage there until you physically disconnect the battery. Now the pros are really finicky on that connector, so you want to lift it up over to the side where you can actually kind of pry a little bit, insert a plastic tool here to just separate the battery off. I have already removed the battery screw, so that screw is missing, and that allows me some clearance to slide just anything that, you know, a piece of plastic, anything that will block that connection. So now I can safely probe around on this board because the battery is disconnected. Okay, so now with the battery isolated, we can just take a look around and see what we can see. We can see connectors, and we know that we just unplugged the screen from there, so we know what that is. And then we can just match some things based on experience to what we know from earlier devices. This is a lot of pattern recognition. This is a lot of experience as we look at this board. This area jumps out at me because I can see some missing components. All right, so we see these little dudes here, these little bricks, and it's pretty clear that we're missing one in that position. And then as I look up here, we're missing another one. Now these things are called coils, inductor coils, and it's pretty unusual to have one just jump off the board, to just kind of jihad and leave. So how did that happen? This is a consequence of bending the board. So these components, you can see how they're really large. They just popped off just like an ice cube in an ice cube tray. Now, why did none of these other little dudes, they're all perfectly fine, and it's because if a component is small, then when that board flexes, it just rides up and down. But a big fat chunk like a coil got popped off. So that's likely how this came to be like this. And as we continue to look around the board, we can see, oh my goodness, we're missing another really giant one. Now we can guess just from the way patterns work that we've got a coil here and a matching coil there. That's probably for like a side A and a side B of some system. These guys are probably related to each other. They have the same markings, the same value. And so we can guess that in these positions that we probably have two really similar components, but we don't know for sure. Now, here's the thing. To actually fix this, I'd really like to know for sure what is the identity of the missing components. I have a really good idea that these missing components are likely a big part of this problem, if not all of this problem, because I know that inductor coils are essential. They have to be there. If you don't have one, then you have blown up a drawbridge. You have an open line. So we are absolutely missing the function that these guys have. So how are we going to figure out what that function is? What's the next step? I would like to know the value of that missing component and the other ones, because if I know the value, I can probably find a replacement and I can probably fix this iPad. How do I go about getting that information? That's what's really tough. I would really like to be able to just look it up, like you could on your boat or your car or your washing machine, or you could even on your old electronics. In our culture, we have always fixed things like this, and we're losing that culture and becoming a disposable society. We've become a disposable society. How do we look this up? And the answer is that I can't. I can't because I don't have access to the schematic for the iPad Pro. Now, what about the argument that, well, if they gave you the schematic, then you could just copy it and you could make the iPad, I can't think of a joke. And to that argument, I will say, I can't find the schematic for this iPad Pro, so I cannot look up this specific component. But I do have the schematic for the iPad Air because it fell off a truck in China and then quickly disseminated around the world. I can find the schematic for the iPhone 4, the iPhone 5, the iPhone 5S, the iPhone 5C, the iPhone 6, the iPhone 6 Plus, the iPhone 6S, the iPhone 6S Plus, the iPhone 7, the iPhone 7 Plus, either the 8 or the 8 Plus I can't find. I can't find iPod Touch, but for many of them I can. And you don't see, I mean, the iPhone 4 schematic has been widely distributed for years, and yet there's not a bunch of copying and cloning that's going on because that schematic is widely available. So my argument against why not make the schematic widely available for iPad Pro is, well, the iPad schematics are widely available for a number of other iPads, and nothing's happened. So if the schematic was a magical key that would allow you to program these chips and to truly copy the intellectual property, which is the software and the programming. This is just hardware. These are just, a city of dudes on a board. And these are not proprietary. This coil, you can get it. Coils are us. There's nothing special about these individual capacitors. They're like Legos. So the organization of the Legos on the board and the actual, manual that says this Lego has this value, that's not special. That's not the magic. There's no secret sauce there. It's just a convenience tool that I could really use right now, but I have no access to that. That really complicates our ability to do repair, this lack of information. So what am I going to do? I'm going to have to do a workaround, and I'll show you what that is. Let's use the tool of pattern recognition and experience and see what this looks like from what we know about other Apple products that are similar. All right, so we can see a chip here. This chip looks identical to the iPhone 10 power management chip. I can see that that chip is surrounded by a bunch of coils. Right? You can see a bunch of coils and a bunch of caps. And to me, that spells power management. So I can guess from experience that the missing coils here are likely part of what the power management chip does, which is to take an incoming battery voltage and drop it down to specific individual baby voltages that go on to power other systems. So we can switch over and look at the iPad Air, for which a schematic did fall off a truck years ago, and see if we can just make a guess. I'd love to be able to look up the exact value, but I'm forced to just take a guess. So let's look at how this is similar or different to an iPad Air. So I'm going to overlay an iPad Air. So here on an iPad Air, we can see this is definitely the power management chip, and we can see this array of small coils and a bunch of capacitors. This looks really similar to what we have going on here in the iPad Air. Now, there's no rule that says that the exact layout has to be the same, but functionally we're probably looking at a power management system. So let's head to the iPad Air schematic. And we can see the power management chip, and then we can see a lot of outputs. We see the word buck, probably has to do with buck conversion, which is a circuit element of having a chip, using some coils, having some caps to take an incoming battery voltage and to convert it to a lesser output voltage. So we can see that all of these guys are coils that are in that system. And for, as it may be here in the iPad Air, these coils are all really similar to each other. 1 microhenry inductors. So we can look through and say, okay, they're all pretty much the same as we look at these different rails. And these rails go on to power for the CPU, power for the GPU, and that kind of gives us an idea of why this iPad would not be turning on. If you knock one of those off, you're going to have an open line. All right, so these are all similar. This one's a little bit different, so we're going to have to take a guess and to just guess that in the iPad Pro 10.5 inch, where we don't have information, that we can apply a practical solution by taking a similar coil from the iPad Air and hoping that it's the same design in the iPad Pro. Now, if we look across time from what we do know, that's often the case. But we have no guarantee, and there's no way for us to look it up. So either we're going to be right, and this iPad is going to turn on, and it's going to work, and we're going to extend the life of this $1,000 device for years, or we're wrong, we're going to waste up a bunch of time, and they're going to end up having to throw away this pocket of the Earth's metals, send somebody, some kid back into a mine to dig up another one so that Apple can sell it for either $1,000 new or $450 if you turn this one in. And that's why we need the right to repair. All right, so I'm going to actually do it now. I'm going to be quiet so that I can fast forward this technical part of the video. Okay, let's harvest from this iPad Air the backlight coil, that's what I think that is, plus the 2 coils that are part of the power management system. All right, it's time to give this a test. So with the battery still isolated, let's connect the screen. All right, I'm going to pull out the battery isolator, press down on that battery Now, ultimately, if this gets fixed, I'm going to want to put a screw there. That ends up being really important. But for testing, we can just press on it. Let's see if this guy will boot. Hey, I see an Apple logo. That's a good sign. Let's see if it'll boot all the way up. Pretty good. It booted. Yay, that's awesome. But theater lights. So that means one of our backlight lines is down, or at least that's what we think it means from our experience working on similar iPads. So we still have some troubleshooting to do. One of our backlight circuits is out. How are we going to find that? So let's go back and look around here. Now, honestly, to solve this, we're pretty much going to have to find another one of these iPad Pro 10.5 inch so that we can start comparing some resistance readings so that we can figure out. There's a lot of variables here. This is what's so frustrating. I don't know for sure that this coil that I've harvested from an iPad Air, I don't know that it can work in this position. I'm pretty sure that it can, but I don't know that. And I would love to be able for Christy to learn how to walk. I'd love to be able to just look up and click, see the value of this component and order it so that I can do a efficient repair. As it is now, this is a variable, along with all kinds of other variables. I have to figure out from nothing how these two backlight circuits work, and I have to make a lot of guesses to do that. So let's get started. We're going to go back and isolate the battery so that I can take resistance measurements without being connected to the battery. All right, let's take some measurements. Now, it's great news. Our iPad technician, Christy, just got back from her spring break in Portugal. So jealous. And she told me a little bit more about her experience with how these circuits work. So now I know that some iPad Pros actually have 3 backlight circuits, but this one has 2, and we can see that they are right here. And I can put a probe on ground and take a diode mode measurement here. Let's actually get in diode mode. There we go. All right, and I'm getting 0.55. That is high compared to our experience. It should be 0.3 on this model. How do we know that? Just from having measured it, troubleshooting backlight problems, which is a common failure point in these. All right, on the other side, the side here that we just did, we have 0.1 at the coil, that's normal, and then here at the bottom of the diode going out to the connector, we have 0.3. Now, how do I know that this is the diode and that it goes out to the connector? I don't. I just know that this looks like a normal diode. This looks like the diode that I do know is the diode from experience in lots of these other iPads. And then I can put my multimeter in continuity mode like this, and I can say, all right, I know that the lines on the side of the diode are going to point out towards the connector. Is this backlight? If it is, it should go to the LCD connector. And if I just kind of probe around, listening for continuity like this, aha, I get a beep. Aha, so now I know that must be the backlight line. And then I can find my backlight filter by saying, what looks like a filter? You look like a filter. Are you backlight? He says no. Are you backlight? Yeah, so that's my one side backlight filter. I can do the same thing and find my way to the other side of the other backlight line. So I know that one of these lines is not working because I have theater lights. What do I do now? Well, let's see. This one is too high. The other one is normal. So I'm going to say, even though I replaced the coil, that seems to have the normal resistance to ground. So I'm going to go with my coil replacement is not most likely the reason why I don't have backlight. I'm going to leave that alone. So how could I have a high resistance in a backlight line? Backlights are really simple. They're usually a power management or backlight driver, a coil, a diode, a row of caps, a filter, and a connector. That's it. They're always like that. They always have been. Of course, the Pro could be different. So if I have too high of resistance out here, then I'm going to have to blame the diode. So let's go ahead and swap that diode. All right, I'm going to take a guess. I'm going to guess that the common backlight diode that has been the backlight diode in every iPad since the iPad 2, that it's going to work here, but I don't know for sure. So we're going to reinstall the new diode with the line in the same orientation as the one that we took out. Let's see if that has made any kind of a difference in our diode mode reading on this line, which the normal value out at the side of the diode facing the connector should be about 0.3. How do we know that? From measuring on a different iPad 10. It's not written down anywhere. We can't look it up. All right, our diode mode is still high at 0.6, so that's not why. Let's answer Bailey. Okay, so the diode, replacing the diode didn't seem to change our resistance. It's still too high. Maybe this coil here is somehow lifted up, like the ice cube problem that we had. So why don't we try lifting and resoldering this coil. Okay, now that we've lifted up and resoldered that coil on there, this is not the coil that was off, this was his brother. Let's see what we have for our diode mode reading now. Still pretty much the same, which is inappropriately high. Now it's hard to think of any other possibilities. The chip, that would be unfortunate. If the chip itself okay, we've got matching readings. It was the coil, the good coil, plus the bad coil. All right, let's test. Okay, so this iPad is working, and this would have been a lot easier if not for the variable of the fact that we don't really know what the value is of some of these components on the board. Now, it's really difficult to try to maintain a donor board collection when you're talking about a $1,000 device that was only in production for a couple of years. It's difficult. We can't just maintain these donor board collections to take off and measure every component on the board. It was really just by chance that we happen to have a lot of pattern recognition for backlight circuits on the iPad Pro because Christy fixes a lot of them and has for a long time. It's a common failure point. So this troll of having a replacement coil that we weren't sure could actually solve the problem, when the actual reason why we ended up with the theater curtains was the other backlight circuit was out because its coil, although intact, was internally damaged. So those things make our job really, really difficult when we have to add in the variable of an uncertainty that we're using the right parts with these devices where we don't have the information that we need in order to do the repair. So as it is, this device is working. There's nothing wrong with this LCD panel. There's really nothing wrong with the battery. There's nothing wrong with the charge port. The only thing that was wrong was a little bit of flexion damage, popped up some big chunks, the coils on the board. Those were replaced and everything is fine. So this is going to go back out working, and I would expect it to have a long life. We'll give it a warranty for the life of the device on this repair because I think it's really robust. But that's really hard to do. This guy's other option, remember, would have been to turn it in to Apple so that Apple could harvest the LCD and shred the board, or who knows what they're going to do to it. And they would get absolutely $0 from Apple for a trade-in value. Or they could turn it in for the out-of-warranty swap if they were willing to buy one of Apple's refurbished devices for $449. This is only 1 year old. They just paid some $800 to $1,000 for this device. That's really expensive when, with the right information and parts, this job can be done. I mean, there's nothing wrong with the screen. That's the majority of the value. This job can be done by independent repair. Just walk in the street and get it done. It's very straightforward. Since doing this video today, I've had to hit pause and stop 3 times for 3 customers that came in with similar devices, not a MacBook, but a laptop, an iPod Touch, things that I had to tell them were not feasible to repair because I couldn't just hit click to look up a part and order it. And that's really, really aggravating. This guy is standing here and I'm having to tell him, I see that you've got this floppy jack. I can't source another one of those very easily. And so it's not feasible to repair. That's really sad. And all of this can be changed if we support and pass the right to repair legislation. So let me tell you a little bit about that before we get out of here. So let's talk about this state legislation, the right to repair. Now, I'm going to tell you a little bit about New York because I live in New York, but this is going on in lots of states that are all over the U.S. And even if you don't live in the U.S., it's still important to pay attention because if this stuff gets passed anywhere, then the manufacturers will likely employ practices that they'll use everywhere. So the easiest way in the US to find out about the current status of right to repair in your state is to go to ifixit.com. ifixit.com has put this really visible state specific, based on where you're logging in, little web doohickey that you can easily click, take action. And that's going to take you to a widget that's specific for your state. So you can fill this out and then you can start writing. Now, this sounds like something that's, who cares, nobody's ever going to read this. That's not true in my experience. I've gone around to lobby in a bunch of different states, including New York, and every state that I've been to, the representatives are totally aware of how many of their constituents are barking about this issue. Now, these right to repair laws have not been voted down or declined. The reason why you don't hear any of them passing is because they don't come up for a vote. Now, a vote, which is the big yes or no, it's hard to get a bill to the point where it can come up for a vote. There's a lot of hashing back and forth to fine-tune the bill in order to say the committee approves it and it's ready for a vote. In order to get that kind of thinking, that action, that's work. In order for the bill to get that kind of work, it has to be the squeaky wheel that legislature wants to take care of that session. So once the budget is done, there's really just a few weeks that are any good idea we can hash out. We're going to hash out the one that is most likely for us to get it to a floor vote and pass. Right to repair is tough because it's really broad and it's something that requires a lot of thought. In order to motivate your assembly people to do that thought, you need to bark really loud, be the squeaky wheel. let's take a look and see what does the bill look like here in New York. So read the actual bill, educate yourself. This is easy to find. So the New York State Assembly, this is actually short. Look at that. That's it. That's it. I've scrolled through the whole thing. Now, a big chunk of the front of it is all definitions. Skip all that. The meat of it is right past the definition. It's not huge to read this. It's not, cancel your weekend. Here it is. In New York, for equipment or parts sold or used in this state and or after blah, 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 the OEMs of such equipment and parts shall make available to independent repair providers or owners of the products manufactured by such OEM in a timely manner. So make available documentation, diagnostic, and repair information, including repair technical updates, schematic diagrams, updates, corrections, etc., etc. So this gets passed, then the job that I just showed you can be done much more feasibly. And so could the line of other local people that are walking into this mom and pop shop that's providing jobs for 6 people in a small rural community. And we're not a unicorn. We're not unique. There are lots of these shops everywhere. And if we could go to a website and look up a part and order it, then a lot more things would become repairable, and we would have a whole lot less of digging up the earth in order to farm out precious metals that go into electronics, when we're going to ultimately just throw them away because a couple of coils popped off the board like ice cubes. That's really not a good idea, according to your great-grandchildren when they, wish they could talk back to you. Now, why has this bill not passed in New York? It's been around in New York for a really long time. And I really thought it had a good chance last year. So last year in 2018, it really seemed like a strong case, and a lot of people that were just like, absolutely, this is the year. And it didn't happen. Now, it didn't not pass. It didn't get called up for a vote. And here's why. So this is a great article that talks about, why this doesn't happen. And the answer is because the tech companies are spending a lot of money. So the money spent on lobbying, $100,000. And when I sat with Nebraska Senator Lydia Brosh, who was the supporter of this bill, and just asked her, hey, how many times have you been visited by the OEMs? She said that Apple had been in her office 6 times. That is really tough to compete with, but you can do it. You're the constituents. You are the people that matter. So make your voice heard, support the right to repair, and this is why it's important.